Okay, today we are going to do something a little bit different. If you notice I am online, you do not see my hand right now. That is because we are not going to follow along with my notes today. You are going to make your own notes based on things that I highlight. So make sure you're following along. You should have your name, class, and date up on your paper already. If you do not, please pause this video. Okay, and then we'll just get started with read number 1. Read to get the gist. Underline and read the first and last sentences. Skim the middle. Ask yourself, what kind of text is this? And get your brain ready to read. So let's just quickly read the first and last sentences. I'm going to highlight them. You should underline them on your paper. So in evaporation, matter changes from a liquid state to a gaseous state or a gas state. Skip to the bottom. Finally, these atoms collect together to form a liquid. You should underline those two sentences. Okay, and then we're going to skim the middle. So let's skim the middle. I'll give you a few seconds to skim the middle. Okay, and that's it. Ask yourself, what kind of text is this? What kind of text is this? Is this a story? Is this an informational text? What kind of text is this? Get your brain ready. Okay, please turn the page to read number 2. We're going to chunk the text now. Break the text up into smaller parts. Plan the places you will stop. Okay, so it looks like we have, let's see, 1, 2, 3, 4, 5 paragraphs. We could chunk it into 3 different sections. This section, the evaporation section, and the condensation section. But since these 2 paragraphs are kind of long, I think I might just do paragraphs again. So please draw a line underneath the evaporation and condensation introduction. Draw a line beneath the first paragraph of evaporation. Draw a line just above the word condensation. And draw a big line below this paragraph and a big line at the end, so that we have 1, 2, 3, 4, 5 different sections, and we have plenty of space for notes over here in the margins. Okay, and then since we have 5 different places to stop, I think that's a good amount. 5 different places to stop in one little article is not bad. So let's turn the page to read number 3. You should be on page 3 right now. Okay, read number 3. Read to annotate. Who, what is the thing that the author is talking about the most? What are the most important details? So, instead of me reading it first, I'm going to give you 2 minutes to read this by yourself. If you feel that 2 minutes is not enough time, you can always pause the video and give yourself more time, but I'll give you 2 minutes starting now. Okay, let's get back into the reading. If you're done reading, great. We're going to read it now together, and I'm going to highlight things, and you need to underline those things in the reading and then make notes in the margins. I'll explain later. So, evaporation and condensation. In evaporation, matter changes from a liquid state to a gaseous state. In condensation, matter changes from a gaseous state to a liquid state. Okay, so the important thing here is that we're talking about evaporation, and it goes from a liquid state to a gaseous state. So I'm going to write in the margins, I would write, if I had a pen, that evaporation equals liquid to gas. You should write that down now in the margins. Condensation is gas to a liquid. So you should write that down in the margins. Those are really important details, and since they're in the introduction, we can assume that they're going to be the most important details in the article. Okay, you should have 2 notes written down on your paper right here, but I'm going to move on. Evaporation happens when a puddle is heated. For example, as the sun heats water in a puddle, the puddle slowly shrinks. The water seems to disappear, but it actually moves into the air as a gas called water vapor. This is an example of evaporation. So I see the word evaporation here in this paragraph twice, once at the beginning and once at the end. Since it is a vocabulary word, we know it's important, but it's also important because it's mentioned twice in one little paragraph. So evaporation happens when a liquid is heated. That's important. Liquid is heated. So we're going to add thermal energy for evaporation. So write a little note to yourself in this area right here that evaporation happens when you add thermal energy. Okay, and then we have an example here. That's a good example. You can write that example down here if you want also, but I'm not going to require it. The water seems to disappear, but it actually moves into the air as a gas called a water vapor. Okay, so here this paragraph is just talking about evaporation happens when liquid is heated and it becomes a gas. Okay, next paragraph. All atoms in a liquid move, but some move faster than others. As the atoms at the surface of the liquid absorb heat energy from the environment, they begin to move around more quickly. When the atoms are moving fast enough, when they have enough kinetic energy to break the bonds that connect them to other atoms, they are able to escape from the surface of the liquid as gas atoms. So I'm seeing liquid, the word liquid here is mentioned a lot. Liquid, liquid, liquid to gas. So since this is talking about evaporation, we know it's talking about liquid to gas. What is it saying about liquid to gas? As the atoms at the surface of the liquid absorb heat energy. Okay, so that's probably important. A liquid absorbs heat energy from the environment. We call heat energy thermal energy. They mean the same thing. They begin to move around more quickly. So as the liquid absorbs more heat energy or more thermal energy, they get faster. So that's what I'm going to write down in the margins, that as the liquid absorbs heat energy, they begin to move around more quickly. That means more thermal energy absorbed means more kinetic energy later down the road. You should write this down in your own words in the margins. Okay, condensation. This is a new topic. Condensation. An example of condensation can be seen when drops of water form on the outside of a glass of water. The drops seem to appear from nowhere, but they actually form from water vapor in the air. So we have an example of condensation here. So maybe our notes can just be the example. So example of condensation is when drops of water form on the outside of a glass of ice water. So you can write down whatever you find important or whatever it takes for you to remember this example in the margins. Okay, next paragraph. Condensation happens when atoms in a gas cool down. I know right off the bat that's important, so I'm going to highlight it right away. You can underline it right away. As the atoms lose heat, they lose energy. As a result, they slow down. They move closer to other gas atoms. Finally, these atoms collect together to form a liquid. Okay, so condensation happens when atoms in a gas cool down. So I know that atoms, let's see, condensation, matter changes from a gas to a liquid. But this is new information that we need to subtract thermal energy or cool down the liquid. So that's what we're going to write over here, that we subtract thermal energy from condensation, or from gas for condensation. So as they lose thermal energy, they lose energy. As they lose heat, they lose energy. As a result, they slow down. This is actually just a really important paragraph. If I were to ever be confused about condensation, I might just want to come back to these two paragraphs and maybe I would understand it better. Okay, by this time you should have a decent amount of notes in the margins. If you don't, go back and reread this article and add some more notes so that you can remember what evaporation and condensation are.